Hello everyone and welcome. In this session, we will be converting the AutoCAD hatch to upright sprinklers in Revit model. This is the second step toward converting this 2D plan into 3D firefighting network in Revit using Dynamo. Back to this sample project, I will open the Level 2 floor plan, where the AutoCAD file was imported in the previous session, and its lines were converted into fire pipes. The detailed items shall be converted to upright sprinklers. Here we have 111 detailed items, therefore the script shall produce the same number of sprinklers. The goal is to place each sprinkler at the center of each detailed item. Now let's launch Dynamo. Before you start, make sure that the Spring Nodes package is installed. Search for the core node. Its name is called Family Instance by point and level. Search for the Levels node, then select Level 2 as a reference level. For the family type, get back to Revit and upload the upright sprinklers family. Follow this path to find the built-in Revit libraries. I will search in the US metric library because this project is in the SI units. Then under the fire protection, select the upright sprinkler family. Back to Dynamo, search for the Family Types node. Then choose the Upright Sprinklers family type. Please note that detail items are not visible in 3D views in Revit. Therefore, it is not possible to get their location. If you try to do so, the result will be null for each item, as shown in this example. To solve this issue, start by selecting the model elements in Revit. Then use this custom node to filter your selection. Search for Categories node. Then pick the detailed item category. The solution will be to create a bounding box around each element, then use their center points to place the sprinklers. In Dynamo, a bounding box represents the smallest rectangular volume that encloses a given geometry. Search for the bounding box node. Bounding boxes are defined by two key points, the maximum point and the minimum point, located at the corners of the physical geometry of each box. To determine the center location, Calculate the midpoint between the minimum and maximum points for each coordinate. Start by isolating the corner points first. Then get the X and the Y location of each corner. The Z location represents the elevation, therefore I will insert it manually to be above the modeled pipes in later stage. Use the code block to set up an equation for each axis. Add any name you prefer for the x-axis variables. You will need one output variable and two input variables to calculate the median value. Do not use the double quotations for the names of the variables. Use brackets for prioritizing, and end the equation with a semicolon. Then connect the x-axis inputs. Check whether the given outputs are the median values. The equation works probably. Copy the equation for the y-axis. You might change the output's variable name. Combine the x and y values into points using this node. Note that all the median points have 0 as default values. I will pick 3000 millimeters to be the elevation value of each sprinkler with reference to level 2. However, connecting this value directly to the list will not make any difference. This is because this list consists of 3 levels. The points are in the first level list. To solve this issue, you might change the order of the input value for the z-axis to the level 1. Make sure to save your work and to change the operating mode in Dynamo to manual. The script is now ready. Click Run, then see the results on Revit. The elevation is correct for the sprinklers, and their location as well. This is the end. Thank you.